video 6 of this series, Patterns. I want to talk specifically about charges. Now, in the last video, I realized it got cut off. I was about to explain that, and you know what? I made a whole separate video for it. So if the last video cuts a little awkwardly, the octahedral valence electron one, it's because I kind of ran out of time and I didn't realize it, and I kept talking for like 5 minutes. So I just made a whole separate video on the charge aspect. So really quickly, I'm just going to put all of these charges in order, and you're going to notice that there's a little pattern with that. And that pattern kind of looks like a little pyramid a little bit. +1, +2, +3, plus or minus 4, -3, -2, -1, and 0. And you can see I kind of color code the periodic table a little bit differently. That's because I really wanted to go over the charge aspect. Now, again, with the charges, nothing is perfect. I'm just going to kind of split this up just a little bit, just to make it a little bit easier maybe to see. But the big part of it is this. Everything orange is positive. Absolutely everything is positive. Everything. That's positive. This whole area's got +1. This whole area down here is positive. 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 This whole area is positive. Again, we might not know what kind of positive they are. We don't. We just talked about in the last video that the transition metals have a different amount of valence electrons, so the charge is different. It actually works with the lanthanide and actinide series at the bottom. So we don't know these, but we do know they're positive. Again, that's because we know that metals lose, and that equals Now, we also talked about in previous videos with the staircase, right, that a lot of the non-metals are going to lose electrons, specifically these in the brown area. So these, well, these would all have a negative charge. And again, we do know what those charges are. This whole column is -3 because they have 5 valence electrons. It's easier to gain 3 than lose 5. This is all -2, and these are all -1. And obviously, here, there is no. I'm going to go CHARG. And no charge over here. And that's because these are stable. That's what's special about them. You already have your 8 valence electrons. You fulfilled the octet rule. You're good to go. Again, over here, we know that if you have 4 valence electrons, it is not easier to gain or lose 1. It's going to be an OR situation. So depending on what's around, you're either going to gain 4 or lose 4. The cool part about this is carbon is the element at the top of this column. And if you didn't know, the reason that's kind of special is because we're carbon-based life forms. There's something called organic chemistry, which is all about carbon. It's an entire year college course on one element. Part of it is because carbon can do a lot of different things because of this plus or minus 4 ability. And that's kind of why we're, in most life forms on Earth, are carbon-based, because there's that flexibility piece. We can gain, lose, or lose electrons to be stable and do what we need to do, which is kind of a cool thing. But just want to provide a really brief video on that. Again, as you can see, a large bulk of the periodic table is positive, but not everything. Okay, and again, these charges work the entire column. And again, that's why these are stable. Should go to the next one. Video 7, can you believe it?